What are the non-modifiable risk factors for cardiovascular disease? Cardiovascular disease can be caused by a variety of risk factors we cannot control. The older you are, the more prone you are to chronic conditions like heart disease or stroke. However, men have a higher risk of cardiovascular disease earlier in life, while women are more at risk after menopause. Women may also experience different symptoms of heart attack that may go unrecognized. You may be more at risk depending on your ethnicity. People of Asian, African, or First Nation descent have higher rates of cardiovascular disease. Your ethnicity may also influence your diet, which can put you at an increased risk for cardiovascular disease. If you have a first-degree relative who has had cardiovascular disease or a stroke before the age of 55 for men and 65 for women, your risk of heart disease doubles, and regular screenings with your doctor are recommended. But there is good news. Up to 80% of premature cardiovascular disease can be avoided and more effectively managed by taking these proactive steps. Quit smoking, be physically active, eat well, achieve a healthy weight, manage your stress and any anxiety or depression, and see your doctor about managing your cholesterol, blood pressure, and blood sugar levels. For more information on cardiovascular disease, please visit our website.
BEaTS Radio, scientists interviewing scientists. Canada is a worldwide leader in science and innovation. However, our communities need to be more connected to current scientific research in order to drive the future of scientific innovation. So what steps can we take to more actively engage and connect our community with scientists and vice versa? Innovation and discovery are at the core of the current efforts of our government, but science sometimes gets slightly complicated to understand. At BEaTS Radio, we will tackle this by having young scientists and early career researchers interviewing scientists and innovators. By dissecting science in simple terms, this will allow our community to better understand the importance of science for our country. Tuning in to BEaTS Research Radio, a podcast streamed from an active lab at the University of Ottawa Heart Institute. My name is Hallie Arnott, and I am the Canadian Biomaterials Society Ottawa Student Chapter President and a graduate student in biomedical engineering at the University of Ottawa, and I'm back here as your host today on this episode. Our goal here at BEaTS Research Radio is to communicate scientific research to the community. We hope that by doing this, we're able to engage people from all different backgrounds about how science from the lab makes its way into the market or clinic. Before we get going with our interview today, I'd like to thank the University of Ottawa Heart Institute, eLife, the Canadian Biomaterials Society, Ottawa Student Chapter, the BEaTS Research Lab, and the Department of Biochemistry, Microbiology, and Immunology with the Faculty of Medicine at the University of Ottawa, who are all supporting us here at BEaTS Research Radio. Also, don't forget to subscribe to our YouTube channel, and you can visit our podcasts on Spotify, Apple Podcasts, Google Podcasts, and a couple of other platforms as well. Here with us today is Dr. Emilio Alarcon. Dr. Alarcon is a scientist in the Division of Cardiac Surgery and the director of the Bio-Nanomaterials Chemistry and Engineering Laboratory, which is part of the BEaTS research team at the University of Ottawa Heart Institute. Dr. Alarcon is also an assistant professor in the Department of Biochemistry, Microbiology, and Immunology at the University of Ottawa. His research is focused around the development and characterization of bio-inspired hybrid nanomaterials. More specifically, his lab works on the fabrication of 3D scaffolds with improved contractile properties and antibacterial properties for the reconstruction of tissues which would have otherwise poor regenerative capabilities. Dr. Alarcon is leading extremely exciting research and has received the Investigator of the Year award at the Heart Institute last year as a result of his successes. But today he's here speaking to us about the importance of collaboration and interdisciplinary science. And he's going to give us some insight on some of his experiences. So thank you very much for joining us today here.
Thank you, Hallie. So first of all, I would like to thank you guys, like Hallie and Alex, that you never get to see Alex, but Alex is in the controls actually. And everyone who actually made this possible. This is it's going to be the 15th episode or something like that. So it has been a long journey. We have learned a lot, but without you guys, you're truly the engine of this. Thank you so much.
Thanks for having us.
Defining interdisciplinarity these days is kind of essential for science. We are facing a healthcare, issue that we didn't face it, a century ago. Our population is aging really, really quickly.
Mm-hmm.
So, for example, now you have you have individuals that are 65, 70 years old. They're physically active. So those individuals, they need different care that they needed actually individuals 50 years ago with the same age. And for addressing a healthcare problem, you have to understand that it's not simply, fixing, like one portion of the tissue. It's actually when a tissue and an organ fails, it's a multifactorial phenomenon.
Right.
So as a multifactorial phenomenon, for example, you have inflammation, you have sometimes vascularization issues, you have biomechanical issues, you have so many different factors that a scientist with one area of expertise is not going to be able to solve the problem.
Right.
So interdisciplinarity, what it actually targets is combining the different areas of expertise into to solve a problem. But solving the problem means the generation of producing a new breed, I call it breed of scientists,
mm-hmm.
that, in this case, you students, they are actually exposed to so many different fields that you're able to come and condense all that information and become the translators. That's the way it is, right? I'm a chemist by training, so I see problems from a chemistry point of view. So I cannot solve everything, but if I sit down with a colleague who is a biologist, he will be able to explain me what is the biology behind that, and I can use my chemistry to try to actually produce materials.
Right.
But if I sit down with an orthopedic surgeon or with a cardiac surgeon, they will provide me with the feedback on what is really the patient needs,
right.
and that I can actually adapt my technology to that. By doing that, you're technically saving many years of research, and also you're saving thousands of, we can save billions of dollars to the healthcare system.
Right. So when you're saying you're as a chemist and you sit down with a biologist and you sit down with a surgeon, that's interdisciplinary science, and you can get a lot further. And that's the work environment that you have here at the Bioengineering and Therapeutic Solutions Laboratory. Can you tell us a little bit about this collaboration and a little bit about the interdisciplinarity here?
So what we have in here is technically we are recruiting students with different backgrounds. We don't only recruit, a student from biochem or biomed. We have a student from, all the way from cardiac surgery and to chemistry, really organic synthesis. And what we do, we put this student, let's say, and this student is going to be supervised or co-supervised by someone in a different field. In our case, I'm the supervisor or the co-supervisor, a chemist. And we have either a biologist or cardiac surgeon, we have an orthopedic surgeon, we have a cornea expert because we do cornea as well. So the idea is truly to have the student exposed to different fields. Mm-hmm. Not expecting the student to become a surgeon, but for the student to become aware of the needs that the cardiac surgery or orthopedic surgery, the cornea surgery really have. Mm-hmm. Because when you understand the boundary conditions, I call them, you are able to design new technologies and materials that are much more efficient at the time you want to use that in a patient. Right. And it's like, you want to take your car to a mechanic, right? And the mechanic doesn't have the expertise for, repairing the engine, but he's an expert in exhaust of the car. Mm-hmm. The guy is not going to be able to fix the engine. So you have to take it to really an expert in that. It's exactly the same. The car has so many different components, and as a human being has a bit more, right? So it's an expert for every part of the part of the car.
Right. So would you say that the lab is more successful because of this, and would you say that your lab has always been formatted in this interdisciplinary, multidisciplinary fashion?
So I grew up in a really conventional laboratory, like a scientist, right? So and my background is physical organic chemistry. So I used to do kinetic models. If the audience is not able to understand what kinetic models are, it's a good thing. You know, I grew up, you know, making all these mathematical models and so on. But it was really, you know, this is what you have to do. This is the reason why you have to do it, and that's it. But I wasn't never happy with that. So when I moved to Canada, probably 11 years ago, I became interested in trying to expand my knowledge, and rapidly I then actually become in the nanomaterials, and then I moved to proteins and I started working with Dr. Griffith in cornea, and I discovered that, you know, the only way to advance in this is really, you know, having the interdisciplinary component. So sitting down and having a cup of coffee and asking an expert, a colleague, what is about inflammation? What is about, you know, why the cornea cannot be regenerated naturally in patients that have the, you know, keratoconus and stuff like that. So when you are exposed to that, you are able to fully understand that, you know, it's good to have a solid background in an area, but it has nothing wrong with you willing to learn from a different field.
Definitely.
Because the more mature you are, the more mature you are able to incorporate that knowledge.
Yes.
And always taking everything from my chemistry background and trying to incorporate it in my new, you know, I call it new knowledge, but you know, new is not that much.
Yeah, definitely. So would you say that this interdisciplinary environment is improving translational ability of research currently?
So, you know, one of the components of developing material for clinical use is the preparation of the material itself. That's something that we call it the standard operating protocols and the good manufacturing practices, GMP.
Yes.
So that is something that, again, I learned from my interaction with other scientists that actually translated technologies already to the clinic. So that is a good example of standardizing the protocol for producing material that are reproducible and so on. So just by doing that, when you have a material that already is standardized, the formulation, the composition is locked. That we call it lock engineering, and you are saving between 5 to 10 years of research. So when you're starting from the very beginning with a clear idea of what do you need, what for, how it needs to be manufactured to be used in the operating room, you're saving lots of time and lots of money to the taxpayers' money, right? So because they are paying for this research, it's everyone's research. So when you're doing that, you're really saving money, and also you're training the new generation of scientists to be aware of that, because following the standard operating protocols and, you know, having materials that are reproducible is not something trivial. That is it's a crisis ongoing in the reproducibility of research in the entire planet.
Right.
So and that is something that we're really proud of, that all the materials we're generating here that is standardized and can be reproduced anywhere.
Right. Yeah. So making the process faster, going from the lab to the clinic.
Exactly.
Right. So you've recently been acknowledged as the Investigator of the Year at the Heart Institute, which is an internationally renowned research institution. So congratulations.
Thank you.
Do you think that your collaborative attitude towards research and really pushing and wanting interdisciplinary research, do you think that this was a contributing factor to your success recently?
I wouldn't call it my success, to be honest, Hallie. I think that everyone's in the lab, including my collaborators, because science doesn't belong to the person who does it, belongs to the community and to our society. So we have great examples in Canada, like C. Frederick Banting, right? So we have to live up to those standards. And I think that collaboration is critical at the Heart Institute. And we are in a really special place. We're in a special place that it was built on the basis of trying to have better healthcare for patients based on research. So and of course, I mean, research from a medical point of view is completely different from a chemistry point of view or biological point of view. But the only way that have those all combined is for them to converge in a clinical need. So there is a clinical need, and we are based on clinical need on patient center. So let's say we have a clinical need, but that clinical need, again, as I said, it has many factors in there. So for trying to have a solution for that particular problem, You have to have all the different disciplines
Right.
come and merge together.
Mm-hmm.
And I think that yes, the interdisciplinary has played a key role. But for doing interdisciplinary science, you have to be willing to learn,
Right.
and to relearn, because sometimes we learn something from the books, but when you're working in the lab and you work with your colleagues, you realize that the apoptosis is something completely different what you learn, and you learn from them, but also they're learning from you.
Right.
But the most benefit out of this, even though it's a little bit stressful for the students, are the students. Because at the end of the day, I told them that they know how to speak chemistry, they know how to speak biology, cardiac surgery, a little bit of all the different languages. But they have a really strong background in one area.
Right.
But they can interact with the rest.
Right, are exposed to all the others.
Exactly.
So, as you were saying, here at the BEaTS research lab, there's a lot of interdisciplinary science going on, a lot of different students from a lot of different backgrounds, and this is something that you've built with your colleagues. What do you think the key components that somebody would need to build an interdisciplinary environment in their lab, and what are the things that you think somebody would need to focus on to have success in this type of environment?
First of all, is having a good team. Like I've been fortunate of having great collaborators, people that also like exactly the same frequency I am. Is like science is for helping patients, science is for helping the community. It's a phrase that it really touched me the first time I came here, that the Heart Institute is seeking for the gift of time. Time is the only thing you cannot buy, right? So, and I think that we're really fortunate of having a wonderful team of trainees and also collaborators over the years, and that's actually been instrumental. If I could give actually a piece of advice to anyone who wants to actually come and be part of the starting interdisciplinarity research, is that to be generous and actually to think about the big picture. And the big picture is not yourself. The picture is the patient. The picture is that what can we actually do for improving the healthcare of Canadians and eventually, the worldwide. So I mean, like the discovery we're doing in Canada, they're really good. And but one thing is Canada, the other thing is the world. But the first stage is trying to actually do something that it will resonate with the community, something that people will see that science is able to actually create an impact in actually healthcare, and then actually you can go further.
Right. So if you could maybe give us an example of a project that was very interdisciplinary and it was successful because of the interdisciplinary, you think?
So last year we published a really exciting paper after almost 5 years of work with, of course, with Dr. Suron, who is the director of BEaTS, and Maruel, and, Katie Rayner, and, Wenbin Liang, many collaborators and trainees here, including Sarah McLaughlin, that is the leading author. It was a result of 4 years of work, 5 years of work actually. But we have the result at the very beginning. The data didn't change, but we had to repeat it many times. We couldn't believe it that it was working so well. It's basically an injectable material that you injected after the myocardial infarction, and it's able to partially restore the cardiac function.
Right.
So in that field, of course I was in charge of the design of the material, the characterization of the material, and we have Dr. Ruel in charge of the cell biology, the animal model. We have Katie Rayner in charge of taking the part of the inflammation. Wenbin Liang in part of the stem cell, our cardiomyocyte cell culture. We have so many different areas of expertise in there that it took us so long for two reasons. One, to try to measure that everything was right and everything was reproducible, and then trying to merge all the different areas of field, and so on. It was a really successful and nice paper, actually, published in Nature Communications. But we're really proud, not only because we published that in Nature Communications, because we were able to combine the different areas of expertise and actually really prove that this material was able to restore the cardiac function. Right. That normally you don't see after the myocardial infarction or heart attack. But we're really proud of that.
Right. Do you think that communication played a big role in the success of that project as well, like on the science, but also just communicating between all the different groups and having everyone on the same page?
Yes,
it's not an easy job.
It's not easy. It takes a lot of work, and I think that most of this work is not done by me, but by the trainees. I think, what I like is, for example, having the trainee, in this case Sarah. If she has a question, she goes to Katie, or she goes to Wenbin, and that's okay, because it's okay for the trainees from learning from other PIs. It's not about you are my student, you're my, no, the trainee has to be exposed to other, different elements, things and so on. So something critical.
So this interdisciplinary environment in science and what you've built here with your colleagues, do you think that that's always been something that's existed in the science field and has always been happening, or has it gained more momentum recently?
I think that at the very beginning, the science, the last century, it was a little bit like this, science, they were all part of one thing. And at some point after the First World War, it started splitting and divided in chemistry, biochemistry, physics, mathematics, biology. And they all evolve at different speeds. But now they're somehow converging because we are realizing that most of the biology could be explained by mathematical models, evolution including, of course. Chemistry is really linked to physics. So they're merging back. It's like they were originating here and then they split and then they're coming back. So this is about time for us to fully merge them again and to produce a new generation of scientists able to mobilize from this field to the other field, because that's the future of science. I mean, we cannot pretend that, of course we need good chemists, we need good physicists, but those with interest in having one foot in here, one foot in here, but exceeding in both, they would actually have the opportunity to do this.
Yes, for sure. And the young students, some in your lab as well, who are going to be the next generation of scientists, do you think that they're more prone to collaboration than maybe the scientists who are starting to retire and moving out of the field?
Yes, I think that they are really willing to collaborate. They're eager to learn different things, and they learn really fast.
Right. That's good. So one other thing before we go, do you think that in a more translational point of view, if you have students who are coming up and becoming more multidisciplinary oriented, do you think that the translation ability of science is going to become a lot faster and a lot easier in the coming years?
Yes, it's going to become faster for sure.
Okay,
that's the future.
All right, you've heard it here first, and we're going to just take a short break now, and we'll be back in a couple of minutes, and we'll speak a little bit more about interdisciplinary collaboration in science.
What are the non-modifiable risk factors for cardiovascular disease? Cardiovascular disease can be caused by a variety of risk factors we cannot control. The older you are, the more prone you are to chronic conditions like heart disease or stroke. However, men have a higher risk of cardiovascular disease earlier in life, while women are more at risk after menopause. Women may also experience different symptoms of heart attack that may go unrecognized. You may be more at risk depending on your ethnicity. People of Asian, African, or First Nation descent have higher rates of cardiovascular disease. Your ethnicity may also influence your diet, which can put you at an increased risk for cardiovascular disease. If you have a first-degree relative who has had cardiovascular disease or a stroke before the age of 55 for men and 65 for women, your risk of heart disease doubles, and regular screenings with your doctor are recommended. But there is good news. Up to 80% of premature cardiovascular disease can be avoided and more effectively managed by taking these proactive steps. Quit smoking, be physically active, eat well, achieve a healthy weight, manage your stress and any anxiety or depression, and see your doctor about managing your cholesterol, blood pressure, and blood sugar levels. For more information on cardiovascular disease, please visit our website.
BEaTS Radio, scientists interviewing scientists. Canada is a worldwide leader in science and innovation. However, our communities need to be more connected to current scientific research in order to drive the future of scientific innovation. So what steps can we take to more actively engage and connect our community with scientists and vice versa? Innovation and discovery are at the core of the current efforts of our government, but science sometimes gets slightly complicated to understand. At BEaTS Radio, we will tackle this by having young scientists and early career researchers interviewing scientists and innovators. By dissecting science in simple terms, this will allow our community to better understand the importance of science for our country. Hello and welcome back to BEaTS Research Radio, a podcast stream from an active lab at the University of Ottawa Heart Institute. If you missed our first segment today, sitting with me is Dr. Alarcon. Dr. Alarcon is a scientist and with the Division of Cardiac Surgery and the director of the Bio-Nanomaterials Chemistry and Engineering Laboratory, which is part of the BEaTS Research Laboratory at the Heart Institute. Today he's here talking to us a little bit about interdisciplinary collaboration in science and why it's so important for the future of science. So to jump back into our interview today, you talked a little bit in our first segment about the interdisciplinary collaborations that you have here at the Heart Institute. Do these collaborations extend further to the global scale?
Yeah. So we have collaborators in the United States.
Mm-hmm.
We have collaborators, I think, in Sweden. We have collaborators in Germany. We have collaborators in Chile,
Mm-hmm.
Argentina. We have many collaborators. So I think that the key in this is when you have to seek for the expertise, what the expertise is,
Mm-hmm.
but also you have to, look for groups that are willing to collaborate in a positive way, right? So it's like people that, they're part of the project, but at the same time they have to have the willingness of collaborating with you, of receiving your students for
Mm-hmm.
for training opportunities and stuff like that. So
Okay.
yeah.
And the collaborations, are they all different expertise in different
Exactly.
countries?
So,
Or?
for example, in the States, we have collaborators at the Massachusetts General Hospital that exercise engineering, so they're
Mm-hmm.
mostly the ones when we design specific, feedback on engineering a device, they have a lot of expertise, so they have mobilized many devices to the clinic. We seek for the help and the guidance, and they're really actually keen to work with us. Like that, we have people, for example, in Chile, they're experts in molecular dynamics. They have not only used the software, but they develop actually the algorithm for modeling large proteins, molecules, and so on. So we seek their advice when we need to have, a peptide. We're working a lot on peptides now, designed for a specific, receptor interaction. So they're helping us with that, and they're saving a lot of time for research.
Wow.
That's what we do.
Right. So what do you think Canada can do to promote interdisciplinary science in our country?
So I think that we're doing fantastically well. I mean, with the New Frontiers Research Fund program, so it's truly, taking a huge step towards, more high risk, innovative, interdisciplinary science. NSERC is doing his incredibly shared as well, and CHR, but basically New Frontiers is taking the lead, which is fantastic. I think that what we need to do more at the level of is at the level of training the new generation of scientists. Programs where we have more, dynamically included, like interdisciplinarity. Because the programs we have these days is, bachelor in chemistry, bachelor in biology, but we should have something more interdisciplinary around that. We have a TMN, which is Translational Molecular Medicine, and the Faculty of Medicine, University of Ottawa, which is somehow filling that gap, having students with a background in biology, background in chemistry, background in engineering coming into this program, and they are receiving a training in molecular medicine. But we could do the same for the PhD program, for a master program, where the students, they receive a training in different areas of expertise for the healthcare sciences. But it's important to understand that the healthcare sciences, you need people with engineering background. You need them for developing the biomedical devices. Without those, we won't have, pumps for the, syringe pump for the patients, like devices, pacers and stuff like that. So we did need them. So that's an important thing, and it's something that we need to have it, like really clear from the people.
Right. Removing the silos right off
Exactly.
the get-go.
We need to do that. The silos.
Right. So in Canada, that's definitely something that we can do, in the university level and starting to remove those silos from the different programs. But what about on the global scale? What would be something, as you guys have done, you've created these interdisciplinary collaborations overseas as well. But what would be maybe a tip to get Canada to start doing that more at a higher level?
So in that area, the New Frontiers Research Program funds they use up, and the transformation is stream, which is basically trying to target that, to create these networkings of collaborations internationally. It was launched early this year or later last year, and it's going to be funding really large groups, like many PIs with international collaborators. I think that's going to be something quite interesting to see. But a more dynamic interaction between Canadian-based scientists with European scientists through European Union grants and stuff like that, it would be kind of interesting. Also, Japan has some opportunities, but the key here is having organizations, institutions, to be willing to support the interdisciplinary research, right? Here at the Hart Institute, they're fantastic. The Faculty of Medicine, they're really supportive. But that is one particular case. I mean, I think that it's easy to judge someone on the basis of their success, but I've been actually fully supported by my institution. So what about those PIs? They have exactly the same, willingness to do the stuff, but they don't have the support to do it. So I think that it's something that it could be done at the institutional level first, and then trying to actually grow from there.
Sure. Did you notice any differences in the way interdisciplinary work was done in Chile, for example, versus how it's done in Canada?
So when I left Chile, almost 11, 12 years ago, I can't remember, and interdisciplinary science didn't exist in Chile at all. So I was trained as a hardcore physical organic chemist because of that. Now they're really starting on that, and they're looking at Canada as a model, which is a good thing. But again, the interdisciplinarity has a problem of how you're going to fund groups, because like money is limited, so you need to distribute the money, the pool of money. But it's certainly different. But the main reason why it's different is because interdisciplinary science for the healthcare in Canada, we do it in the basis of universal healthcare. In Chile, they don't have that. It's private and public. So you have again, two different angles competing in there. But that is starting, I think.
You think it's starting?
Yeah,
Well, that's good.
Quite promising.
Have you encountered any barriers when trying to collaborate with other researchers, or when you're trying to collaborate with them and their obstacle or barrier came up? How did you maybe resolve it?
Yes, I have found. So I think that one of the key ones is a little bit of, I remember I never collaborated with a person because I used to was a proposal for that person, but that individual was more worried about who's going to be the corresponding author and stuff like that. And I think that you shouldn't put that up front. I think that we have to make sure that science and the benefit of the community and to our patients has to be first. So I'm proudly say that all the collaborators I have, they have the same, line of thinking as I do. Like we're doing this for our communities, with our communities, for training the next generation of scientists. I think as long as you don't lose the point, which is the big goal here, which is the big prize. The big prize is seeing you guys, the next generation of trainees, being successful, contributing to the society. That is the most rewarding award you're gonna get ever as a scientist. Not even a Nobel Prize actually can get you that. Seeing you guys 10, 15 years after you finish your degree, doing great, and having a happy life and contributing to the society. I think that's all about it.
Right.
And but sadly, there's some scientists that are not thinking exactly the way I do. And
right.
Some call me like a little rainbow guy, but it's okay.
So do you have any tips for researchers who are struggling to connect with multiple teams and want to start interdisciplinary collaborations but are having, these obstacles are coming up? What would be something to look for?
So I think that you need to look for good mentors. I've been fortunate having great mentors. And I think that the mentors are really key and for the early career researchers. And mentors they don't necessarily need to be like senior scientists. It can be actually someone as you, as an early career researcher, with a little bit more expertise in this and that. When you're going to conferences, trying to network a lot, trying to actually meet people, even though you might not like it, try to go and meet people because scientists were people, right? So you know the guy, you know the person behind the scientist. Sometimes it's even more interested than the scientist itself. And trying to generate network from there and get it started. I mean, work hard and don't be actually sad when you don't get grants funded, because most of the actually success is based on failure. So we cannot forget that failure is part of learning.
Right, definitely. So, what about collaborations outside the lab? So you spoke a little bit about like speaking with other at conferences, let's say. Do you think that socializing and networking with other groups outside the lab at conferences, is that a really good first step or really supportive for collaborative research?
Yes, it is. Like I like going to conferences when I can learn about other research. So sometimes at the conference I got the craziest ideas inspired on other research. And when I feel that the research my ideas inspired on their work, I normally share with them. And that is when actually collaboration starts. I think that is important. It's something that we might not be able to do that well now for trainees, but I always encourage my guys to go on the conference and meet people and learn about other work. So I mean, sometimes you don't get to see the person, but you see the presentation and you say like, oh, that is a good tip for presentation. Oh, that's a good paper I need to read and stuff like that. So that is the very beginning of science, right? So I mean, you have to start to be curious. You have to be always curious, and that's an easy way to do it.
Definitely. So interdisciplinary collaboration requires a lot of organization, as we spoke about earlier in the other segment. As more of the director and the mentor for others, would you say that you're really involved in each step, or do you give a lot of freedom to the students while you're working interdisciplinary with other teams?
So you cannot force creativity.
It's a hard question. But
creativity comes with freedom, right? I'm always tell the guys that. So just to give you an example, normally when someone joins our team, they start with 1 or 2 projects, but easily my postdocs, the guys in here, they can handle up to 7 projects at the same time. The key is organization, right? Dedicating a lot of amount of times to this project and so on, and delegating. Delegating is super important, and that's the reason why we're so integrated. So delegating is important because when you're delegating this task, you are actually taking that workload out of you, and you can actually take another project. And also having a plan B for everything. We have plan B, C, D all the way, right? Because sometimes, most of the time, I'm going to be honest with you, things don't work the way you were expecting them to work. So now in terms of organizations, it is extremely important. So I'm counting the number of projects we have in here. I'm now handling around 14 different projects, right? I need to dedicate a certain amount of time every week on the top of all the admin thing I need to do and the institute and all the paper reading. So it's exhausting, but in the long run, it's really rewarding to see how students, they were originally at the beginning really overwhelmed by the amount of work they have to do, but when they realize they're free, they can learn as they go, they feel relaxed, and they're giving you actually excellent work. Now, some people, they need more guidance. Yes, it's true. But this is part of the mentorship, right? It's part of being a supervisor. If you have someone that needs a little bit more help, that's okay. You spend more time with that person. But there are people, like other of my trainees that have been actually used. Just come, get used to it, and then just fly.
Right, and speaking with kind of all the other students
exactly
also helps a lot. Right. Do you think that the interdisciplinary collaboration with students in your lab, do you think it's positively benefited them, or you see that they've learned more during the process than others?
Yeah, they do learn, because they learn to learn from others. Not to never overlook the expertise, and also not only the expertise in the field, also the multicultural expertise, right? Because one thing is, for example, in Chile, that back in the days, I didn't have money for buying the equipment, so I was trained how to build equipment. And I have passed along to the guys, and the guys are able to assemble equipment now. So we're saving money, but at the same time, they're learning a bit of engineering. So that is a key feature within the team. So if we don't know how to actually works, we don't use it. We need to learn how it works. That's the first stage. And so the guys are also learning from that. Every country, every culture, they do things differently, and learning why they do it differently is a really valuable thing.
Right.
And it's a plus for them. So I really enjoy that too.
Right. I guess one last question before we go. Aside from the research, more, would you say that BEaTS, what you've created here, the BEaTS research, the BEaTS Research Radio as part of the BEaTS Research Lab, would you say that this is also a completely different interdisciplinary collaboration and motivation towards communicating science to the community? Because here we've collaborated a lot with the communications team, who's helped us out a lot. Do you think that aside from just the research, that communication can even be interdisciplinary as well?
Yeah, I think that science, the ultimate goal of science is benefiting the community, right? If you're not communicating science, it's the same if you're not doing science. It's exactly the same. So I think communicating science in simple terms for the community, with the community, is key for advancing science. Because, the trust of the community and the trust of the society is in medical advances. For example, now we have the coronavirus, outbreak and so on. So they're relying on a universal vaccine. They're relying on us. So we have a social responsibility as scientists. And one of those social responsibilities is outreaching the community, inspiring other actually future scientists, like students and so on, and actually helping them to become scientists, and one day benefiting Canada and the world.
Right. Wow. Well, very nice to talk to you about interdisciplinarity in science, and also thanks for having us here at BEaTS Research Radio and continuing to communicate science to the community. We'll catch you next week on BEaTS Research Radio, and thanks to all of our listeners for tuning in.
BEaTS Radio, scientists interviewing scientists. Canada is a worldwide leader in science and innovation. However, our communities need to be more connected to current scientific research in order to drive the future of scientific innovation. So what steps can we take to more actively engage and connect our community with scientists and vice versa? Innovation and discovery are at the core of the current efforts of our government, but science sometimes gets slightly complicated to understand. At BEaTS Radio, we will tackle this by having young scientists and early career researchers interviewing scientists and innovators. By dissecting science in simple terms, this will allow our community to better understand the importance of science for our country.